here's what we got. We're going to actually look at this problem of the skeet. Clay target mass 0.20 kilograms, that's 200 grams, I think I put in the original problem. Fired an angle of 40 degrees, so right over here we're at 40 degrees. That's not drawn to scale, of course. So theta here is 40 degrees. And with a velocity of 27 meters per second. Okay, so when it reaches the maximum height, it's hit from below by a pellet with a mass of 50 grams, traveling vertical upward with a speed of 200 meters per second. What I said is it was fired with a speed V initial of 200 meters per second. And then they collide and the pellet embeds into the skeet. And the figure at left shows the trajectory of the skeet. If the pellet had not hit, it would have just continued on this path. And then once it does actually hit, it just follows the dotted line path. And so the two questions are, what is the total height, maximum at the top here, height max of the pellet skeet combo, and what is the extra distance, the additional distance, delta x, the skeet travels as a result of the collision with the skeet. Okay, so we start this by saying the 27 meter per second can be broken into horizontal and vertical components. So vertical components, so the velocity in this direction is 27 times sine of 40, and over here it's 27 times cosine 40. So the vertical initial speed, V horizontal, is this way, vertical V is this way. So the vertical speed initial is equal to 17.36 meters per second. And down here, the horizontal speed is equal to 20.68 meters per second. Now, both of these are going to be valuable at different parts of the solution, but we need them both. So this 17.36 will help us get to the height. The height then will help us figure out how fast this pellet is actually moving when it collides. So the height that it gets to is equal to the height of this. It can be found a few different ways. Probably the easiest way is to say we could find the average speed between what its start speed is, and the final speed at the top here is actually 0. So the average speed is half of this original vertical speed. So height is just a distance, and velocity is distance over time. So average velocity is distance over time. So this is the height. So average velocity times time will equal the height change. So the average velocity, remembering really quickly that average velocity in a accelerated system where it's accelerating uniformly is V final plus V initial over 2. Well, V final in this case, after it launches from here, it goes up to here. V final is 0, right? Because all we're looking at is in the interval from where it starts as it's launched to the point where the skeet is hit by the pellet. That's where the V final is, and then in that case, this V final is 0. So V final is 0, so V initial over 2 equals the average velocity. So average velocity times time will give us the height. Well, the time that it's in the air has to be found by saying we take the v initial, acceleration equals v final minus v initial over t. So final velocity of this event from here to here is 0. So if we trade places with A, which is just g, if we trade places with g and t, then we can say negative v initial over g equals t. So we take negative v initial, which is negative 17.36, divided by g, which is negative 9.81, and that'll give us the time it takes to get to the top, which is equal to 1.77 seconds. 1.77 seconds. Okay, so time it takes to get to here is 1.7 seconds. If this is traveling upward at 17.36, half of that average, 17.36 divided by 2, is 8.68. So then this turns out to be 8.68 meters per second, right? Because the average velocity is the final velocity or initial velocity divided by 2 right here, because the final velocity is 0. So 8.68 times 1.77 seconds, and it gives us a height of 15.36. Well, actually, we could take that and call it 15.4 meters. So the height that it gets to inside here is 15.4 meters. Okay, now we can use that height and the fact that the pellet is traveling at 200 meters per second initially, and say, okay, what is the speed at which it hits here? And you could say, well, v final squared minus v initial squared equals 2g change in height. Now we know the change in height is 15.4 meters. We know g, we know v initial is 200. So v final is all we're solving for. So v final squared equals 2g delta h plus v initial squared. So we take the square root of that whole thing. Ooh, let me undo that. That's not good. Okay. Squiggly as that is, that's what we need. So we need 19.62 times 15.4 plus v initial is 200 squared, and then we take the square root of all that. Okay, so then v final at the top for that is equal to 199.24. 199.24 meters per second. Okay, so that's still pretty much 200. So the velocity of the skeet here hits at 199.24 meters per second. Now, a couple things to keep in mind. Is we've got two collisions happening. We have a horizontal collision. So horizontal collision, and then we have a vertical collision. So we're going to treat each one the same, but we just have to keep in mind which is which. So M1 V1 plus m2v2 is equal to m1 plus m2 times v final together horizontally. So we're going to do this. Okay? And then over here, we're going to say m1 v1 plus m2 v2 is equal to m1 plus m2 times the v final vertically. Okay? So, horizontally speaking, this is, the skeet is completely horizontal. Traveling along here, straight along at the top, it's just all horizontal, and the pellet is all vertical. So the pellet has 0 horizontal speed. So we would say this is 0. Okay, so M1 V1 for the skeet will be calculated based on its horizontal speed. Plug all that in. Get that velocity. Do the same thing for the other, only this one is 0. Find that velocity, then you're going to just have a vector to find a resolution for it. All right?